Good day, everyone. Welcome to today's class. Today, we're considering solve problems that involve first resonance and second resonance in a resonance tube. I'm talking in the sense that the resonance we're going to be considering will be dealing with first harmonic and the second harmonic. And don't forget that second harmonics is also referring to as the first overtone. That's what I'm trying to say. Sometimes you are asked to look for the first harmonic in the resonance tube. Always know that the second resonance is referred to as the second harmonics, and second harmonic is referred to as the first overtone. And let's see the diagram. We want to draw the diagram now, but before you draw the diagram, read the question very, very well. The shortest length of the air column in the resonance tube. The shortest length means the first resonance that takes place in the resonance tube. And resonance tube always refers to as closed pipe, in which one end of the tube is closed while the other end is opened. Okay, and also example of closed pipe will be found in organ pipe. Now let's see, you can see it here. Got it. You have uh, here is the length, and at the upper part of the tube you have what we call end correction, which is insignificant, very, very insignificant. Is end correction. From the end correction, you can see the length goes cover the end correction, the total length of the tube. But we are going to be the from the end part of the end correction to the close end is the lambda over 4. Okay. Why do we have the end correction? In a tube, when it's being filled with the air column and you want to blow a pipe, there be a particular space close to your mouth that air does not totally filled round, but it is insignificant, it is negligible because very, very minute, very small. That's why I will show you where it cancels out. When the calculation it cancels out, which shows that it's very, very small. When you are blowing a pipe, you see that air will be circulating around the pipe, inside the pipe, but there will be a space where your mouth touches, and at that point, very significant, which the air does not fully circulate around, touches, it does not, uh, air does not fully fill the pipe, but it's very, very insignificant, very small. Okay. That's why you have this one to be first resonance, which is the shortest length. And that first resonance, we can still have first harmonic, and also we still have fundamental frequency, F naught. This is what can be found in the first resonance, which is the shortest length. And let's see the second, because we are told that uh, and the next resonance length is 0.32 meters. Okay, the next resonance length is the second harmonic, and under the next resonance length, you have a complete full circle touching the close end, while the other end is opened. Let's see, you can see it. The length L, but at the upper end there is end correction, which is very close to your mouth, so which when you're blowing air into the pipe, this part, your mouth will be very close to the end, in which is very negligible, it's insignificant. The C will cancel out later to show us that it's insignificant. Okay, from the other end part of this end correction to this point, This point, that is a quarter, that's lambda over 4. From the end of this point, complete circle is lambda over 2. How do you get lambda over 2? Don't forget that 2 quarter can be found in this complete circle. Okay, now the total length lambda. Let's see, lambda. How do you get this lambda over 2? Let me show you. Lambda over 4, lambda over 4 plus lambda over 4. SCM is 4. 4 goes in 4, 1 times lambda, lambda. Plus 4 goes in 4, 1 times lambda, lambda, which is 2 lambda over 4. 2 here 1, 2 here 2, which is lambda over 2. That's why I got this lambda over 2, because 2 of this lambda over 4 is in lambda over 2. That's how I got this. Now I want to get the complete length. Okay, you can see that the complete length covers to the end of the end correction. The upper end is not involved in the length because it's negligible, insignificant. Now, let's see L total, which is the total length, will be lambda over 4 plus lambda over 2. SCM is 4. 4 goes in 4, 1 times lambda, lambda. 2 goes in 4, 2. 2 times lambda is 2 lambda, which is 3 lambda over 4. Now, the total length is 3 lambda over 4. Okay? Now, example of closed pipe is organ pipe. Now, this is second resonance and the second harmonic, and also first, you can call it first overtone. First overtone start from the second harmonic. Okay, when you are asked to look for the third resonance, you have two complete circles touching, being towards the downside, and the quarter opened. Okay, now let me show you how, before we go into this solving for the frequency, let me derive a formula for you and show you how this end correction cancel out. Now your length L1, let's call it L1, this L2. The length L1 is the addition of the end correction and the lambda over 4, because that what makes a complete circle. The total length involves end connection and lambda over 4. But the reason why this one is insignificant, I will show you. Now L1 equals lambda over 4 plus end correction, which is C. Let's call that one equation 1. That is a first resonance. Now, the second one, L2 equals 3 lambda over 4 plus C. You can see the complete length involve end connection and 3 lambda over 4. 3 lambda over 4 plus C. That's equation 2, second resonance. Okay? You can see that the length of L2 is greater than the L1. Now, you can see from here looking at it, you can say subtract equation 1 from equation 2. When you do that, you now say L2 minus L1, L2 minus L1, write this one first, equals to 3 lambda over 4 plus C minus, open your bracket to involve the whole of lambda over 4 plus C. Lambda over 4 plus C. Close your bracket. Now, L2 minus L1 equals 3 lambda over 4 plus C minus lambda over 4, negative and positive as minus C. Okay? C cancel out. Can you see how C cancel out? It shows that the end correction is negligible. L2 minus L1, when you say something is negligible, it means that you don't need to consider the the end correction when you are solving the problem. Now equals to 3 lambda over 4 minus lambda over 4. Now L2 minus L1 equals, what's the LCM? 4. 4 goes in 4, 1 times 3 lambda, minus 4 goes in 4, 1 times lambda, which is 3 lambda minus lambda, that's 2 lambda over 4, 2L1, 2L2. Now, your L2 minus L1 equals lambda over 2. Now, cross multiply, make lambda the subject of the formula. Lambda equals 2 into L2 minus L1. Okay? Now, let's see the general formula. Let's call this one equation 3. I can say V equals to F lambda. This equation 4. Substitute lambda equals to 2 into L2 minus L1 in equation 4. Now V equals F times 2. Instead of writing lambda, put 2 into L2 minus L1, which is equals to 2F L2 minus L1, equation 5. Please, this equation 5 is very important. Let me rewrite it. Your V equals 2F into L2 minus L1, equation 5. Please, a very important equation in which we are asked to look for the velocity of sound in air. You make use of this formula. Please take note. Now, in this question, we are asked to look for frequency. Divide both sides by 2 into L2 minus L1. When you do that, you have V divided by 2 V V divided by 2 open bracket L2 minus L1 equals 2F L2 minus L1 divided by 2 into L2 minus L1 divided by, don't forget you have F here, 2F divided by 2 into L2 minus L1. 2 L2, 2 into L2 minus L1, cancel these two, and L2 minus L1, you are left with frequency. From here, now have your frequency to be equals to V over 2 into L2 minus L1. Now let's write our parameters out. From here, you have L1 to be 0.20 meters. L2, let's try the parameters out. L1 equals 0.20 meters. L2 equals 0.32 meters. And your V equals 340 meter per seconds. Now, let's substitute our value. Our V is 340 divided by 2 into, what's our L2? 0.32 minus L1 0.20. Now your frequency now equals 340 divided by 2 into 0.32 minus 0.20, that means 0.12, equals to 340 divided by 2 times 0.12, that's 0.24. When you divide that, you have 1,416 0.67 hertz. We have 6666, but let's round it up to two decimal places. And when you have a number greater than 4, which is 5 above, you take it as 1, add it to the previous one. The previous one here is 6. But since you're having 666, you round it up as 1, take it, add it to this 6 that was here, it becomes 7. That's the frequency of vibration. That brings us to the end of the class. Please don't forget to subscribe to the channel for more updates, and also don't forget to leave your question in the comment section. Thanks for watching. See you in the next class. Have a blessed day.